AGN feedback in an infant galaxy cluster. The LOFAR-Chandra view of the giant FRII radio galaxy J103025052430 at Z17. In the nearby universe, jets from AGN are observed to have a dramatic impact on their surrounding extragalactic environment. Their effect at the cosmic noon, the epoch when star formation and AGN activity peak, is instead much less constrained. Here we present a study of the giant radio galaxy 103025052430 located at the center of a protocluster at redshift Z1.7, with a focus on its interaction with the external medium. We present new LOFAR observations at 144 MHz, which we combine with VLA 1.4 GHz and 0.57 keV Chandra archival data. The new map at 144 MHz confirms that the source has a complex morphology, possibly consistent with the hybrid morphology classification. The large size of the source gave us the possibility to perform a resolved radio spectral index analysis, a very unique opportunity for a source at such high redshift. This reveals a tentative flattening of the radio spectral index at the edge of the backflow in the western lobe, which might be indicating plasma compression. The spatial coincidence between this region and the thermal X-ray bubble C suggests a causal connection between the two. Contrary to previous estimates for the bright X-ray component A, we find that inverse Compton scattering between the radio-emitting plasma of the eastern lobe and the CMB photons can account for a large fraction of its total 0.57 keV measured flux. Finally, the X-ray bubble C, which is consistent with a thermal origin, is found to be significantly overpressurized with respect to the ambient medium. This suggests that it will tend to expand and release its energy in the surroundings, contributing to the overall intracluster medium heating. Overall, 103025052430 gives us the chance to investigate the interaction between AGN jets and the surrounding gas in a system that is likely the predecessor of the rich galaxy clusters we all well know at Z0.
Next article.
Effects of Barnett magnetic dipole-dipole interaction on grain growth and destruction. Rapidly spinning magnetic grains can acquire large magnetic dipole moments due to the Barnett effect. Here we study the new effect of Barnett magnetic dipole-dipole interaction on grain collisions and grain growth. Assuming grains spun up by radiative torques, we find that the collision rate between grains having embedded iron inclusions can be significantly enhanced due to Barnett magnetic dipole-dipole interaction when grains rotate superthermally by radiative torques. We discuss the implications of enhanced collision rate for grain growth and destruction in the circumstellar envelope of evolved stars, photodissociation regions, and protostellar environments. Our results first reveal the importance of the dust magnetic properties and the local radiation field on grain growth and destruction.
Next article.
Wet compaction to a blue nugget, a critical phase in galaxy evolution. Cross lists for Friday the 24th of February.
Next article.
BUDHIESIV deep 21 cm neutral hydrogen optical and UV imaging data of Able 963 and Able 2192 at Z02. In this paper, we present data from the Blind Ultra Deep High Environmental Survey, which is a blind 21 cm high spectral line imaging survey undertaken with the Westerbork synthesis radio telescope. 2 volumes were surveyed, each with a single pointing and covering a redshift range of 0.164 Z 0.224. Within these 2 volumes, this survey targeted the clusters Able 963 and Able 2192, which are dynamically different and offer unique environments to study the process of galaxy Evolution within clusters. With an integration time of 117 by 12H on Able 963 and 72x12H on Able 2192. A total of 166 galaxies were detected and imaged in high. While the clusters themselves occupy only 4% of the 73,400 mpc3 surveyed by BUDHIES, most of the volume consists of large-scale structures in which the clusters are embedded, including foreground and background overdensities and voids. We present the data processing and source detection techniques and counterpart identification based on a wide-field optical imaging survey using the Isaac Newton telescope and deep ultraviolet galaxy imaging. Finally, we present high and optical catalogs of the detected sources as well as atlases of their global high properties, which include integrated column density maps, position velocity diagrams, global high profiles, and optical and UV images of the high sources.
Next article.
Modeling gas around galaxy pairs and groups using the Q0107 quasar triplet. We examine to what extent disk and outflow models can reproduce observations of HI gas within a few virial radii of galaxies in pairs and groups, using highly sensitive HST-Cos and FOS spectra of the Q0107 quasar triplet covering Li alpha for Z1, as well as a deep galaxy redshift survey including VMOS, DEMOS, GMOS and MUSE data. We test simple disk and outflow models against the HI absorption along 3 lines of sight through 9 galaxy groups in this field. These can be compared with our previous results in which these models can often be fit to the absorption around isolated galaxies. Our models can reproduce 75 of the 28 identified absorption components within 500 km of a group galaxy. So most of the HI around groups is consistent with a superposition of the CGM of the individual galaxies. Gas stripped in interactions between galaxies may be a plausible explanation for some of the remaining absorption. But neither the galaxy images nor the galaxy and absorber kinematics provide clear evidence of such stripped material. And these unexplained absorbers do not preferentially occur around close pairs of galaxies. We find HI column densities typically higher than at similar impact parameters around isolated galaxies, as well as more frequent detections of OV than around isolated galaxies.
Next article.
Demographics of hierarchical black hole mergers in dense star clusters. With about 100 mergers of binary black holes detected via gravitational waves by the LIGO Virgo KAGRA collaboration, our understanding of the darkest objects in the universe has taken unparalleled steps forward. While most of the events are expected to consist of BHs directly formed from the collapse of massive stars, some may contain the remnants of previous BBH mergers. In the most massive globular clusters and in nuclear star clusters, successive mergers can produce second or higher generation BHs, and even form intermediate mass BHs. Overall, we predict that up to 10, 1 or 0.1 of the BBH mergers have one component being a 2G, 3G, or 4G BH, respectively. Assuming that 500 BBH mergers will be detected in O4 by LVK. This means that 50, 5, or 0.5 events, respectively, will involve a 2G, 3G, or 4G BH. If most sources are produced dynamically in dense star clusters, with their distinctive signatures of higher masses and spins, such hierarchical mergers offer an unprecedented opportunity to learn about the BH populations in the densest stellar systems and to shed light on the elusive intermediate mass BHs that may form therein.
Next article.
Absence of the predicted 2022 October outburst of OJ-287 and implications for binary SMBH scenarios. The Project MOMO was set up to test predictions of binary supermassive black hole scenarios and to understand disk jet physics of the Blazar OJ-287. After a correction, the precessing binary SMBH model predicted the next main outburst of OJ-287 in 2022 October, no longer in July, making the outburst well observable and the model testable. We have densely covered this period in our ongoing multi-frequency radio, optical, UV, and X-ray monitoring. The predicted outburst was not detected. Instead, OJ-287 was at low optical UV emission levels, declining further into November. The predicted thermal Bremsstrahlung spectrum was not observed either, at any epoch. Further, applying scaling relations, we estimate a SMBH mass of OJ-287 of 10.8 m_Sun. The latest in a sequence of deep low states that recur every 1–2 years is used to determine an upper limit on the Eddington ratio and on the accretion disk luminosity. This limit is at least a factor of 10 lower than required by the PB model with its massive primary SMBH of 1010 m_Sun. All these results favor alternative binary SMBH models of OJ-287 that neither require strong orbital precession nor a very large mass of the primary SMBH.
Next article.
The Meerkat-Fornax survey I-survey description and first evidence of RAM pressure in the Fornax galaxy cluster. The Meerkat-Fornax survey maps the distribution and kinematics of atomic neutral hydrogen gas in the nearby Fornax galaxy cluster using the Meerkat telescope. The 12-Deg2 survey footprint covers the central region of the cluster out to RVIR and stretches out to 2 RVIR towards southwest to include the NGC 1316 galaxy group. The high column density sensitivity ranges from 5E19 cm2 at a resolution of 10 down to 1E18 cm2 at 1, and slightly below this level at the lowest resolution of 100. The high mass sensitivity is 6E5 m_Sun. The high velocity resolution is 1.4 km/s. In this paper we describe the survey design and high data processing, and we present a sample of 6 galaxies with long, one-sided, starless high tails radially oriented within the cluster and with measurable internal velocity gradients. We argue that the joint properties of the high tails represent the first unambiguous evidence of RAM pressure shaping the distribution of high in the Fornax cluster. The disturbed optical morphology of all host galaxies supports the idea that the tails consist of high initially pulled out of the galaxy's stellar body by tidal forces. RAM pressure was then able to further displace the weakly bound high and give the tails their present direction, length and velocity gradient.
Next article.
AGN Storm 22 ultraviolet observations of MRK 817 with the cosmic origins spectrograph on the Hubble Space Telescope. We present reverberation mapping measurements for the prominent ultraviolet broad emission lines of the active galactic nucleus MRK 817 using 165 spectra obtained with the cosmic origins spectrograph on the Hubble Space Telescope. Our ultraviolet observations are accompanied by X-ray, optical, and near-infrared observations as part of the AGN Space Telescope and optical reverberation mapping. Program 2. Using the cross-correlation lag analysis method, we find significant correlated variations in the continuum and emission line light curves. We measure rest frame delayed responses between the far ultraviolet continuum at 1180A and Li alpha, lambda 1215A, NV lambda 1240A, CIVOIV lambda 1397A, Civ lambda 1549A, and He lambda 1640A using segments of the emission line profile that are unaffected by absorption and blending, which results in sampling different velocity ranges for each line. However, we find that the emission line responses to continuum variations are more complex than a simple, smoothed, shifted, and scaled version of the continuum light curve. We also measure velocity-resolved lags for the Li alpha and Civ emission lines. The lag profile in the blue wing of Li alpha is consistent with virial motion, with longer lags dominating at lower velocities and shorter lags at higher velocities. The Civ lag profile shows the signature of a thick rotating disk, with the shortest lags in the wings, local peaks at 1500 kms1, and a local minimum at line center. The other emission lines are dominated by broad absorption lines and blending with adjacent emission lines. These require detailed models, and will be presented in future work.
Next article.
HEROES, the Hawaii Rosita Ecliptic Pole Survey Catalog. We present a 7-band catalog derived from a Subaru Hyper Supreme Cam imaging survey of the North Ecliptic Pole. The survey, known as HEROES, consists of 44 square deg of contiguous imaging reaching median 5 sigma depths of G 26.5, R 26.2, I 25.7, Z 25.1, Y 23.9, NB 816 24.4, NB 921 24.4 mag. We reduced these data with the HSC pipeline software HSC Pipe, and produced a resulting multi-band catalog containing over 25 million objects. We provide the catalog in 3 formats: a collection of HSC Pipe format forced photometry catalogs, a single combined catalog containing every object in that dataset with selected useful columns, and a smaller variation of the combined catalog with only essential columns for basic analysis or low memory machines. The catalog uses all the available HSC data on the NEP and may serve as the primary optical catalog for current and future NEP deep fields from instruments and observatories such as Scuba 2, Rosita, Spitzer, Euclid, and JWST.
Next article.
Resonant infrared irradiation of CO and CH3OH interstellar ices. Solid phase photoprocesses involving icy dust grains greatly affect the chemical evolution of the interstellar medium by leading to the formation of complex organic molecules and by inducing photodesorption. So far, the focus of laboratory studies has been mainly on the impact of energetic ultraviolet photons on ices. But direct vibrational excitation by infrared photons is expected to influence the morphology and content of interstellar ices as well. However, little is still known about the mechanisms through which this excess vibrational energy is dissipated, and its implications on the structure and ice photochemistry. In this work, we present a systematic investigation of the behavior of interstellar relevant COO and CH3OH ice analogues upon resonant excitation of vibrational modes using tunable infrared radiation, leading to both the quantification of infrared-induced photodesorption and insights in the impact of vibrational energy dissipation on ice morphology. We utilize an ultra-high vacuum setup at cryogenic temperatures to grow pure CO and CH3OH ices, as well as mixtures of the two. We expose the ices to intense, near monochromatic mid-infrared free electron laser radiation to selectively excite the species. The dissipation of vibrational energy is observed to be highly dependent on the excited mode and the chemical environment of the ice. All amorphous ices undergo some degree of restructuring towards a more organized configuration upon on resonance irradiation. Moreover, IR-induced photodesorption is observed to occur for both pure CO and CH3OH ices, with interstellar photodesorption efficiencies of the order of 10 molecules cm2s1. Indirect photodesorption of CO upon vibrational excitation of CH3OH in ice mixtures is also observed to occur, particularly in environments rich in methanol.
Next article.
First bistro observations of the dark cloud Taurus L1495 AB10. The role of the magnetic field in the earliest stages of low-mass star formation. We present Bistro Survey 850 μm dust emission polarization observations of the L1495 AB10 region of the Taurus molecular cloud, taken at the JCMT. We observe a roughly triangular network of dense filaments. We detect 9 of the dense starless cores embedded within these filaments in polarization, finding that the plane of sky orientation of the core scale magnetic field lies roughly perpendicular to the filaments in almost all cases. We also find that the large-scale magnetic field orientation measured by Planck is not correlated with any of the core or filament structures, except in the case of the lowest density core. We propose a scenario for early prestellar evolution that is both an extension to and consistent with previous models, introducing an additional evolutionary transitional stage between field-dominated and matter-dominated evolution, observed here for the first time. In this scenario, the cloud collapses first to a sheet-like structure. Uniquely, we appear to be seeing this sheet almost face-on. The sheet fragments into filaments, which in turn form cores. However, the material must reach a certain critical density before the evolution changes from being field-dominated to being matter-dominated. We measure the sheet surface density and the magnetic field strength at that transition for the first time and show consistency with an analytical prediction that had previously gone untested for over 50 years.
Next article.
Study of central intensity ratio of Seyfert galaxies in nearby universe. We use the recently discovered simple photometric parameter central intensity ratio determined for a sample of 57 nearby Seyfert galaxies to explore the central features of galaxies and their possible connection with galaxy evolution. The sample of galaxies shows strong anti-correlation between CIR and mass of their central supermassive black holes. The SMBH masses of ellipticals are systematically higher for a given CIR value than that for lenticulars and spirals in the sample. However, the correlation between CIR and central velocity dispersion is weak. CIR appears less influenced by the excess flux produced by the central engine in these galaxies, when compared to spectroscopic parameters like velocity dispersion and OIV flux, and proves a fast and reliable tool for estimating central SMBH mass.
Next article.
On the observability of recurrent nova super remnants. The nova super remnant surrounding M31N 2008-12A, the annually erupting recurrent nova, is the only known example of this phenomenon, as this structure has grown as a result of frequent eruptions from 12A. We might expect to see NSRs around other RNE. This would confirm the RN-NSR association and strengthen the connection between novae and type Ia supernovae, as NSRs centered on SNEA provide a lasting, unequivocal signpost to the single degenerate progenitor type of that explosion. The only previous NSR simulation used identical eruptions from a static white dwarf. In this paper, we simulate the growth of NSRs alongside the natural growth erosion of the central WD. Within a range of environments, accretion rates, WD temperatures, and initial WD masses, the subsequent evolving eruptions create dynamic NSRs tens of parsecs in radius comprising a low-density cavity. bordered by a hot ejecta pile-up region, and surrounded by a cool high-density, thin shell. Higher density environments restrict NSR size, as do higher accretion rates, whereas the WD temperature and initial mass have less impact. NSRs form around growing or eroding WDs, indicating that NSRs also exist around old novae with low-mass WDs. Observables such as X-ray and H-alpha emission from the modeled NSRs are derived to aid searches for more examples. Only NSRs around high accretion rate novae will currently be observable. The observed properties of the 12A NSR can be reproduced when considering both the dynamically grown NSR and photoionization by the NOVA system.
Next article.
Automatic line selection for abundance determination in large stellar spectroscopic surveys. Conclusions: the method provides a diagnostic of where to focus to get the most out of a spectrograph, and is easy to implement for future instruments, or for pipelines that require line masks.
Next article.
Extension of general relativity with Mond limit predicts novel orbital structure in and around galaxies. Detailed knowledge of the different classes of stellar orbits that can be accommodated in a given galactic potential is a prerequisite when building self-consistent models using, for instance, the Schwarzschild technique. Furthermore, observational properties of galaxies depend on what these classes of orbits are and on the presence of chaos in the systems. In the realistic case in which the starting point for modeling is not a gravitational potential, but an observed density distribution, we will require a gravitational theory to make the connection between the stars that we see and the movement these stars may be having. The argument can be turned upside down, understanding what orbits may be allowed by each gravitational theory may give us a greater insight on what these theories are and on how we can test them. Our aim is thus to understand novel properties of orbits that are predicted by the latest extension of the Mond phenomenology into the relativistic world. We integrated orbits numerically in a fixed density distribution. The potential required for such integration was obtained also numerically by assuming different gravitational models. We find that thanks to the presence of a mass term in the field equations, the theory can allocate new classes of orbits that do not exist in Newtonian gravity nor standard Mond. We discuss consequences that these new families of orbits can have in nonlinear cosmological structure formation, as well as explore a possible alternative model for galactic structure based on them.
Next article.
SCFF-DPS, a fast N-body code for simulating disk halo systems. A fast N-body code has been developed for simulating a stellar disk embedded in a live dark matter halo. In generating its Poisson solver, a self-consistent field code which inherently possesses perfect scalability is incorporated into a tree code which is parallelized using a library termed Framework for Developing Particle Simulators. Thus, the code developed here is called SCFF-DPS. This code has realized the speed-up of a conventional tree code by applying an SCF method not only to the calculation of the self-gravity of the halo but also to that of the gravitational interactions between the disk and halo particles. Consequently, in the SCFF-DPS code, a tree algorithm is applied only to calculate the self-gravity of the disk. On a many-core parallel computer, the SCFF-DPS code has performed at least 3 times, in some case nearly an order of magnitude, faster than an extremely tuned tree code on it, if the numbers of disk and halo particles are, respectively, fixed for both codes. In addition, the SCFF-DPS code shows that the CPU cost scales almost linearly with the total number of particles, and almost inversely with the number of cores. we find that the time evolution of a disk halo system simulated with the SCFF-DPS code is, in large measure, similar to that obtained using the tree code. We suggest how the present code can be extended to cope with a wide variety of disk galaxy simulations.
Next article.
Dynamical age of the Tucana Horologium Young Stellar Association. The Tucana Horologium Association is one of the closest young stellar groups to the Sun, and despite the close proximity, its age is still debated in the literature. We take advantage of the state-of-the-art astrometry delivered by the third data release of the Gaia space mission, combined with precise radial velocity measurements obtained from high-resolution spectroscopy to investigate the dynamical age of the association. We perform an extensive traceback analysis using a combination of different samples of cluster members. Metrics to evaluate the minimum size of the association in the past and models for the galactic potential to integrate the stellar orbits back in time. The dynamical age of 38.51.68.0 mir that we derive in this paper is consistent with the various age estimates obtained from isochrone fitting in the literature and reconciles, for the first time, the dynamical age of the Tucana Horologium Association with the age obtained from lithium depletion. Our results are independent from stellar models and represent one more step towards constructing a self-consistent age scale for the young stellar groups of the solar neighborhood based on the 3D space motion of the stars.
Next article.
Mean field dynamo due to fluctuating turbulent diffusivity. In systems where the standard alpha effect is inoperative, one often explains the existence of mean magnetic fields by invoking the incoherent alpha effect, which appeals to fluctuations of the mean kinetic helicity. Previous studies, while considering fluctuations in the mean kinetic helicity, treated the mean turbulent kinetic energy as a constant, despite the fact that both these quantities involve second-order velocity correlations. The mean turbulent kinetic energy causes both turbulent diffusion and diamagnetic pumping of the mean magnetic field. In this work, we use a double averaging procedure to analytically show that fluctuations of the mean turbulent kinetic energy can lead to the growth of a large-scale magnetic field even when the kinetic helicity is zero-pointwise. Constraints on the operation of such a dynamo are expressed in terms of dynamo numbers that depend on the correlation length, correlation time, and strength of these fluctuations. In the white noise limit, we find that these fluctuations reduce the overall turbulent diffusion, while also contributing a drift term which does not affect the growth of the field. We also study the effects of non-zero correlation time and anisotropy, diamagnetic pumping, which arises due to inhomogeneities in the turbulent kinetic energy, leads to growing mean field solutions even when the eta fluctuations are isotropic. Our results suggest that fluctuations of the turbulent kinetic energy may be relevant in astrophysical contexts.
Next article.
Microlensing of the broad emission line region in the lensed quasar J1004 4112. J1004 4112 is a lensed quasar for which the first broad emission line profile deformations due to microlensing were identified. Detailed interpretations of these features have nevertheless remained controversial, based on 15 spectra obtained from 2003 to 2018. We revisit the microlensing effect that distorts the SIV broad emission line profile. We show that the microlensing-induced line profile distortions in image A, although variable, are remarkably similar over a period of 15 years. They are characterized by a strong magnification of the blue part of the line profile, a strong demagnification of the red part of the line profile, and a small to negligible demagnification of the line core. We used the microlensing effect to constrain the broad emission line region size. geometry, and kinematics. For this purpose, we modeled the deformation of the emission lines considering three simple, representative BLR models: a Keplerian disk, an equatorial wind, and a biconical polar wind, with various inclinations with respect to the line of sight. We find that the observed magnification profile of the sieve emission line can be reproduced with the simple BLR models we considered, without the need for more complex BLR features. The magnification appears dominated by the position of the BLR with respect to the caustic network, and not by the velocity-dependent size of the BLR. The favored models for the sieve BLR are either the Keplerian disk or the equatorial wind, depending on the orientation of the BLR axis with respect to the caustic network. We also find that the polar wind model can be discarded. We measured the sieve BLR half-light radius as R122.82.01.7 light days. This value is smaller than the BLR radius expected from the radius-luminosity relation derived from reverberation mapping, but it is still in reasonable agreement given the large uncertainties.